Order of operations. This example comes from the OpenStax College Algebra textbook. In this example, we're given these 5 expressions and we're asked to evaluate them using the order of operations. An order of operations is commonly referred to as PEMDAS as a way of remembering the systematic order in which we should simplify expressions. PEMDAS starts with a P for parentheses. This could also include other grouping symbols. The E in PEMDAS comes next for exponents. This would also include radicals, since radicals are a type of exponent. And then, importantly, the M and the D are written together because they are done at the same time. Multiplication and division are done together and from left to right. And then addition and subtraction are also done together from left to right. Taking this shorthand for remembering the order of operations, we can break it down into 4 steps, one for each row here, where for step 1, we simplify expressions with any of those grouping symbols, such as parentheses. Step 2, we simplify any exponents or radicals. In the 3rd step, we move on to multiplication and division, and in order from left to right. Lastly, addition and subtraction in order from left to right. So, looking at our first example, we have this expression, and for step 1, we're told to simplify any grouping symbols. So we have these parentheses. In our first step, we will simplify those. 3 times 2 is 6, and that is still being squared, and 6 plus 2 is 8. I left the parentheses here just to show multiplication, but there's no simplification to do inside that parentheses. It only has the 8. But we can now move to the next step, which is to simplify any exponents or radicals, and we do have an exponent. So 6 squared is 36. That's the only exponent. Next, in step 3, we have multiplication and division left to right. Multiplying would give me a minus 4 times 8, 32. Lastly, we're left with addition and subtraction. There's only one operation, subtraction. 36 minus 32 is 4. We've simplified as much as possible. In example B, we're given this expression, and again, starting with grouping symbols in our first step, this radical is acting as a grouping symbol, grouping that 11 minus 2 together under the radical. This fraction has grouped this expression in the numerator. Even though they're not parentheses, they are being grouped together. And so simplifying, that numerator 5 squared minus 4 has an exponent and subtraction, and the exponent gets done before the subtraction. So 5 squared is 25, and under the radical, 11 minus 2 is 9. Notice that we still have the 25 minus 4 grouped together in the numerator, so I would move to that next. 25 minus 4 is 21 over 7 minus the square root of 9. No more grouping symbols. We can turn to step 2, exponents and radicals. The radical square root of 9 can be simplified to just 3. So 21 over 7 minus 3. Our next step calls for multiplication and division. And since we have division, that would be next. 21 divided by 7 is 3. Lastly, addition and subtraction. 3 minus 3 is 0. So simplifying this expression gave us just 0. And for our example C here, starting with grouping symbols, I can see that the absolute value is used as grouping, as well as the parentheses. Simplifying, inside the absolute value, 5 minus 8 is a negative 3. Simplifying inside the other parentheses, 4 minus 1 is 3. Next, exponent and radicals. No exponents or radicals. But before we get to just multiplication and division, we do have an absolute value. The absolute value of negative 3 is 3, but notice the other negative just comes down. We then have multiplication and division. Multiplication is here, so rewriting once more, 3 times 3 is 9. And now that we're left with just addition and subtraction, we do addition and subtraction left to right. 6 minus 3 is 3, plus 9 gives us 12. So we've simplified to just 12. In this example, when we start with grouping symbols, the numerator is grouped together and the denominator is grouped together. So we would start by simplifying this, and we will need to see which has priority in the numerator and in the denominator. In the numerator, we have subtraction and multiplication, with multiplication coming before subtraction, so that multiplication would be 3 times 2, which is 6. And then in the denominator, we have multiplication, subtraction, and an exponent. So in the denominator, the exponent has the highest priority, meaning I'll leave the multiplication and subtraction. 3 squared is 9. And then we still have grouping symbols where the numerator and denominator are grouped together. So in the numerator, 14 minus 6 is 8. In the denominator, we have multiplication and subtraction. Multiplication is done before subtraction. So next would be that multiplication. 2 times 5 is 10 minus 9. Still grouped together in the denominator is 10 minus 9, which is 1. We now have just one operation left, division. 8 divided by 1 is 8. And lastly, for E, doing our grouping symbols first, these are grouped together. And actually, this part of the expression is grouped together, but inside of that is another grouping. So we have nested grouping. For nested grouping, we just work from the inside out, and I can still go left to right with that first parentheses. 5 times 3 simplifies to 15. Inside, in the innermost grouping symbol, we have 6 minus 3, which is 3. And notice that's the only operation we're doing during that first pass, but that we still have a grouping symbol. But the grouping symbol has subtraction and an exponent. The exponent would need to be done first. So we can rewrite this as 3 minus 4 squared is 16. Even though I've made a couple of simplifications, I still have this grouping symbol. And 3 minus 16 is a negative 13. We have no more grouping symbols, no more exponents. So multiplication and division, I have multiplication twice here. I can do those from left to right. 7 times 15 is 105. Negative 2 times negative 3, a positive 26. Lastly, addition and subtraction. From left to right, 105 plus 26, 131 plus 1, 132.